practice problems on concurrent forces. Let's take a look at some practice problems here. I'll work out some problems for you, and then when we're done, I'll provide you with some practice problems with answers. Practice problem number 1. Vinny and Nadia, trapeze artists, must swing across a large pit in the circus floor without a safety net. If Vinny and Nadia's combined weight is 1,200 newtons, calculate the tension in one segment of the trapeze. There are 2 ropes holding up the bar that Vinny holds onto. Just before they start their swing, if the pair makes an angle of 35 degrees with the vertical. First, I'll draw a little picture to assist me with the problem. So I have a trapeze, which is a bar supported by 2 cables or ropes. And hanging on to this trapeze, we have Vinny, Nadia, his partner, is also hanging on to Vinny. And the combined weight of this pair of trapeze artists is 1,200 newtons. We know that weight always acts in the downward direction, so I'll draw a vector pointing downward and label the magnitude, 1,200 newtons. Now, to make this problem simpler to see, instead of drawing just a picture, I'm going to take this picture and create what's called a free body diagram. The free body diagram only shows the forces that are involved, and it leaves out unnecessary objects. So what we have here is, let's just represent the trapeze as a single force, because we know that since there are 2 cables, each one of them must support half the total weight of the trapeze artist. So I'll have a force, let's call it T, for tension. And we know that this force makes an angle of 35 degrees with the vertical. We have the downward force of weight. And I'll label weight here as 600 newtons, since we're interested only in the tension on a single cable of the trapeze. Now, we know that before they make their swing, that the pair is in what's called equilibrium. They're not moving before they begin their swing. This means that all the forces acting here must be balanced. So if there was a downward force of 600 newtons at this point, then there must be a vertical component of the tension on the cable, which also is equal and opposite to the downward force of weight. So I'll label this as force vertical, FV, and we know that FV must balance the weight. So it is also a 600 Newton force. In order to find the tension on the trapeze cable, make a right triangle here. We already know the vertical component of this tension, so now consider that it also has a horizontal component. These 2 force vectors together must combine to give a resultant, which is the tension on the cable. So using trigonometry, we can calculate that tension. The cosine of this angle, 35 degrees, is the adjacent side, FV, over the hypotenuse. So cosine 35 equals FV over the tension, T. And we know what FV is equal to. Cosine of 35 degrees is 0.8192. That must equal 600 divided by T. Multiply both sides by T. To get T out of the denominator, remember T must be in the numerator, and we must isolate that variable. Get it alone by itself on one side of the equal sign. So So now we divide by 0.8192. And the tension on one part of the trapeze cable equals 732 newtons. Practice problem 2. Two farmers carry a large 10-kilogram bucket of corn kernels for planting by holding the ends of a rope with the bucket attached at the middle. If there is an angle of 130 degrees between the two segments of the rope, what is the tension in each part? So we have a bucket with some corn in it. It's being carried by two farmers by means of a rope, and we know that the bucket is attached to the middle of the rope, and that the two segments of this rope make an angle of 130 degrees with one another. We know that the bucket must have weight because it has mass, and that weight is a downward force. So I'll draw Fw for force of weight, and that must equal mass times gravity. So the weight of the bucket is 10 kilograms. Remember, you must use kilograms when finding weight. Acceleration due to gravity is 9.81 meters per second squared. So the weight of the bucket is 98.1 newtons. We only need to find the tension in one segment of the rope, as these two segments are identical to one another. Since the bucket is exactly in the middle, it means that each farmer carries or supports half the total weight of the bucket. Now, I would recommend that you take this tension, this vector, and split it up into its two component vectors, like so. We know that there is a horizontal force that pulls away from the center, but the force that's most useful to us is the lift, or the vertical component of the tension on that cable or rope. Both sides of this picture are identical, so solving for either rope segment will give us the same result. This is only because the bucket is attached in the middle. This is much easier to see than to try and indicate the up force here acting on the bucket, because we're not really quite sure how long to make that vector. But we do know that each farmer supports half the bucket's weight, which is why I recommend to students that they resolve their vectors to either side, as I've indicated here in green. We know that both vertical forces, when added together, must equal the weight of the bucket. So each person supports half the weight. Or 49.05 newtons. By using the sine function, we can obtain tension, since we know that Fv, or the opposite side here, is equal to 49.05. From geometry, we can also determine the angle theta that's needed. We know that in a straight line, there are 180 degrees altogether. So if I subtract 130 from 180, this would leave 50 degrees left over. And those 50 degrees must be equally divided between my two angles here. So if 2 times theta is 50 degrees, then angle theta must equal 25 degrees. So the sine of 25 degrees would be the opposite side, which is the vertical force, over the hypotenuse, which is our tension. Sine of 25 degrees equals 49.05 divided by t. So t must equal 49.05 divided by sine of 25 degrees. The tension on one segment of the rope is 116 newtons. You should access Concurrent Forces Practice Problems Part 2 in order to see some additional practice and get some new practice problems to try on your own.